Today I am here with my new video on topic hyperbola. A hyperbola is a locus of a point which moves in a plane such that its distance from a fixed point S called the focus bear to its perpendicular distance from fixed straight line ZK called the directrix. A ratio always greater than 1. The ratio is called the eccentricity and it's denoted by E. According to this definition, we plot or we trace a parabola, then we will find such type of graph. It is a parabola. This is the y-axis and this is the x-axis. According to definition, it is a locus of a point. Suppose this point P of coordinate x, locus of a point which moves. This is a moving point in a plane such that its distance from a fixed point S, distance of this point through S, fixed point S is called the focus. This point S is called the focus, and its perpendicular distance from a straight line ZK called the directrix. A ratio always greater than 1. The ratio is called the eccentricity and is denoted by the ratio of PS, and suppose this point be PM. So its ratio always should be equal and it is called eccentricity of the hyperbola. A and A dash vertices, this straight line and this straight line are called directrix of the hyperbola. Write down. According to figure P be a point moves in a plane. P be a point moves on a plane, and S and S dash be a fixed point. It is called the focus of the hyperbola. And fixed straight line ZK and Z dash K dash be directrix of the hyperbola. The directrix of the hyperbola. O be the center of hyperbola. O be the center of hyperbola. Now the coordinate of focus S A comma 0 and minus A comma 0, where A is the eccentricity of the hyperbola. E is the eccentricity of the hyperbola, where E is the eccentricity of the hyperbola. Equation of hyperbola Equation of hyperbola. Equation of hyperbola x square upon a square minus y square upon b square is equals to 1. X square upon a square minus y square upon b square is equals to 1. This is the equation of hyperbola. If we draw a straight line from this, so it is called latus rectum. This can be called latus rectum. Now, some more important points about hyperbola. First, vertices. First, vertices. The coordinate of vertices. The coordinate of vertices a, comma 0 and a dash minus a comma 0. This point A and this point A dash is called the vertices of the hyperbola, and its coordinate be a comma 0 and minus a comma 0. The coordinate of a comma 0, and the coordinate of a dash minus a comma 0 means this distance a and this distance b minus a. Okay, clear? Center of the hyperbola. Center of the hyperbola. Here O be the center of hyperbola, and its coordinate be 0 comma 0. Transverse axis. Transverse axis of hyperbola. A dash is the called transverse axis of the hyperbola. Means this A dash, it is called the transverse axis of the hyperbola. A dash is called transverse axis. A dash is called the transverse axis, and the length of transverse axis is equals to 2a. Because the coordinate of a is a comma 0 and the coordinate of a dash minus a comma 0. We can determine the length of this transverse axis by using the distance formula. It will be 2a, and the equation of this axis equals to y equals to 0. So equation of transverse axis. Now equation of transverse axis, y equals to 0. Now conjugate axis. Now conjugate axis. This axis is called the conjugate axis. This y-axis is called the conjugate axis. Conjugate axis. While this axis is called the conjugate axis, and the length of conjugate axis be 2b. Length of the conjugate axis 2b. And the equation of conjugate axis, equation of conjugate axis is equals to x is equals to 0. Now length of the latus rectum in figure this point will be the focus S, and suppose if L and it be L dash. So L dash is called the latus. The length of the latus rectum, but one important thing, latus rectum passes through the focal. Latus rectum passes through the focal. Always passes through the focal. Means we can say it is the perpendicular from a point on the focus. Suppose this is hyperbola. Suppose this point be S, then it is called the latus rectum. Always passes through the focal. The length of the latus rectum be 2b square upon a. 2b square upon a. Equation of directrix. Equation of directrix. X is equals to A upon E. X is equals to A upon E is the equation of directrix. And for left side, x is equals to minus A upon E. Means we can say x is equals to plus minus A upon E. Because hyperbola have two directrices. So the equation is x equals to plus minus A upon E. And eccentricity of the hyperbola. Eccentricity of the hyperbola since b square is equals to a square e square minus 1. Since b square is equals to a square e square minus 1. After solving this, we will get the eccentricity of the hyperbola. Means this can be written as b square divided by a square is equals to e square minus 1, and this can be written as 1 plus b square upon a square is equals to e square. Means therefore e is equals to under root 1 plus b square upon a square.
A square plus b.
Okay, a square plus b square by a square. It can be also written as a square plus b square upon a. Okay, this is the formula for eccentricity. Okay, now write down a question. Find the eccentricity of the hyperbola. Find the eccentricity of the hyperbola 9x square 9x square minus y square is equals to 1. Find the eccentricity of the hyperbola. Eccentricity of the hyperbola.
Root 10.
Solution. You know the equation of hyperbola. Equation of hyperbola: x square upon a square minus y square upon b square equals to 1 represent a hyperbola. X square upon a square minus y square upon b square equals to 1 represent the hyperbola. Mean coefficient of x square always should be 1. Coefficient of x square always should be 1. So this equation can be written as nine x square minus y square equals to 1 mean x square upon 1 by 9 x 1 by 9 minus y square upon 1 is equals to 1. Okay, this is the equation number first and this is the equation number second. Comparing equation 1 and 2. Comparing equation 1 and 2, we have a square is equals to 1 by 9. A square is equals to 1 by 9. This a square is equals to 1 by 9 and b square is equals to 1 and b square is equals to 1. Therefore, eccentricity of the hyperbola. Therefore, eccentricity of the hyperbola equals to e square equals to 1 plus b square upon a square. Now putting the value of a square and b square. So use square equals to 1 plus b square equals to 1. So put here 1 and a square. A square equals to 1 upon 9. Mean 1 plus 9 upon 1. E square equals to 1 plus 9 upon 1 means e square is equals to 10. Therefore, eccentricity of the hyperbola E is equals to under root 10. Answer. E equals to under root 10. Next question. Find the find the coordinate of focus, find the coordinate of focus, eccentricity and lattice rectum of the hyperbola. Find the lattice rectum eccentricity foci, focus means both the focus, okay, and coordinate of focus, that is the foci, and axis of hyperbola 4x square minus 9y square is equals to 36. Question: find the lattice rectum comma eccentricity, focus and axis of hyperbola 9x square minus 4x square minus 9y square equals to 36. Okay, first of all we arrange in a proper way like a equation of parabola. So 4x square minus 9y square is equals to 36, dividing both the sides by 36 because we need 1 in right hand side. Reason, we need 1 in right hand side, so divided by 36. So 4x square divided by 36 minus 9y square upon 36 is equals to 36 upon 36 is equals to x square upon 9 by 36 divided by 9. So y square upon 4 is equals to 1. Equation number 1. We know equation of hyperbola x square upon a square minus y square upon b square equals to 1. Comparing equation 1 and 2. So a square, after comparing, a square equals to 9 and b square is equals to 4. It means a equals to 3 and b is equals to 2. A is equals to 3 and b is equals to 2. Now first of all we find eccentricity of the hyperbola. So eccentricity, therefore eccentricity of the hyperbola. So eccentricity e square equals to 1 plus b square upon a square, right? E square equals to 1 plus 4 upon 9 means e square equals to 13 upon 9. Therefore e equals to under root 13 upon 3. Now next we find the focus. The coordinate of S A E comma 0 for focus coordinate of A, coordinate of S, A, E, comma 0. Therefore, A equals to 3, A equals to 3, and E equals to under root 13 upon 3, comma 0, means coordinate of S under root 13, comma 0. Similarly, for second focus, we will get minus 13, comma 0. So the coordinate of foci equals to coordinate of foci plus minus under root 13 upon 0. Now find out the lattice rectum. You know the length of the lattice rectum 2b square by a. So put the value of b square and a square. Next question from ncert book, exercise number 11.4. Question number 4. Find the lattice rectum, eccentricity, foci and axis of hyperbola 16x square minus 9y square is equals to 576. This is the question number 4 from exercise number 11.4. Solution. Given equation 16 x square minus 9y square is equals to 576. Dividing both the sides by 576. Dividing both these sides by 576. 16x square divided by 576 minus 9y square divided by 576 is equals to 576 upon 576 is equals to x square 576 divided by 16, it become 36 minus y square upon 64 is equals to 1. Now it become a equation of hyperbola like x square upon a square minus y square upon b square is equals to 1. Comparing both the equation, we will get the value of a square and b square. After comparing, we will get a square is equals to 36 and b square is equals to 64. It means a is equals to 6 and b equals to 8. Now find the eccentricity. Find the eccentricity E is equals to under root 1 plus a square plus b square by a. Okay. Yes. Similarly, we can find the focus, directrix, and axis of the hyperbola. Next question. Question number 7. Find the equation of hyperbola. Find the equation of hyperbola whose vertices plus minus 2 comma 0 and foci is given plus minus 3 comma 0. Solution. Means focus of hyperbola 3 comma 0 and minus 3 comma. Now one more question. Question number 7. Find the equation of hyperbola. Find the equation of hyperbola whose vertices plus minus 2 comma 0, foci plus minus 3 comma 0. We know that focus means this plus minus 3 comma 0 written as 3 comma 0 and minus 3 comma 0. And you also know focus of hyperbola. Focus of hyperbola. The coordinate of S a e comma 0 and the coordinate of S minus a e comma 0. It means this is equals to 3 comma 0 and minus 3 comma 0. Comparing both the sides, a equals to 3. A equals to 3 means E is equals to 3 upon A. Let is the question number first. E equals to 3 upon A. Now, vertices given means vertices A is equals to 2 comma 0 and A dash is equals to minus 2 comma 0. And you know the vertices of hyperbola A comma 0. It means A comma 0, 2 comma 0 means A equals to 2. We have A equals to 2. Now putting the value of A in equation number first. So we will get eccentricity of the hyperbola equals to 3 upon 2. Okay. Now you have eccentricity, you have A. Find the value of B. You know E square equals to 1 plus B square upon A square means E square equals to A square plus B square upon A square. By cross multiplication, E square into A square is equals to A square plus B square. By cross multiplication, E square into A square is equals to A square plus B square. E square A square, इस A square को सेंड कर देंगे, सेंड लेफ्ट हैंड साइड minus A square is equals to B square. Therefore, B square equals to E square. E square means 3 upon 2 whole square. E square means putting the value of E, 3 upon 2 whole square. A square. A square means 2 square minus 2 square. 3 square 9 and this 2 square we cancel out minus 4. Means E square A square and A square send in the left hand side. Now putting the value of A square and A square, E equals to 3 by 2, substituting here 3 by 2 whole square and A equals to 2 square minus 2 square. This 2 square and 2 square we cancel out. We have 9 minus 4 equals to 5. Means B square equals to 5. Therefore, equation of hyperbola. We know that equation of hyperbola x square upon A square minus y square upon B square. So, x square upon A square minus y square upon B square is equals to 1. So x square, the value of A square is 4 minus y square upon B square is 5 is equals to 1. Answer. Yes. So with the help of focus. With the help of eccentricity, we can determine equation of an hyperbola. That's all about your conic section.